Thank you very much, Jens, for this introduction. I will try to fix as much as I can. First of all, to say I come from Teesside University, which is located in Middlesbrough, not in London, but that's all right. We are located in the northeast of England, and I will be presenting the project called Dr. Bob, which stands for Demand Response in Blocks of Buildings. So this project really comes as a result of an effort over the past number of years where Teesside University was involved in different projects working on optimization of energy management systems, and particularly now we have the pleasure of coordinating the project, which is funded by EASME. It includes 10 partners from 5 European countries. Apart from Teesside University, we have a pleasure of working with CSTB, which is a research institute from France, with Siemens from the UK, the Energy Management Division, R2M Solutions, small SME from Italy, Nobatec Research Center from France as well, Gridpocket, an SME from France, Dynaworks from the Netherlands, Fondazione Poliambulanza, which is a hospital complex from Italy, Servelect, an energy service company from Romania, and the Technical University of Cluj-Napoca from Romania as well. We have 4 demonstration sites, namely in the UK, France, Italy, and Romania. The project started in March last year, so we are now 1 year into the project. And I'll be presenting the first results shortly. But really, what the aim of the project is to find ways how we can demonstrate the economic and environmental benefits of demand response on the level of blocks of buildings. And why we are looking at blocks of buildings, because really, the more buildings you have, the bigger the benefits are, and the bigger the potential to realize the savings by shifting energy demand, not only on a single level, but maybe shifting within different buildings. The actors to whom we are trying to develop solutions include the distribution network operators, energy retailers, transmission service operators, energy service companies, IT providers, aggregators who bring these different buildings together, and then obviously the building owners and facility managers. But what is really demand response? You might be aware that when you look at the operation of the grid, typically, you experience 2 peaks, the morning demand, the morning peak, and the evening demand. Now, as we see more and more renewables coming into the grid and connecting to the grid, you see that this availability of renewable energy resources is not uniform throughout the day. In fact, as the sun has its solar peak sometime around noon, you will have more renewable energy coming from the PV into the grid, and also the wind resources are not uniform as well. So there is an idea that if you can shift the demand to the time where the energy is actually available on the grid, you will be actually making the most use of renewables. Also, as the more renewables come to the grid may find it difficult to cope with such a large amount of energy which is not used. And we have already a situation in a number of European countries where the renewable energy sources had to be disconnected from the grid because grid couldn't cope with that. For example, in Germany, in Denmark, which has a lot of wind, in Belgium, and so on. So one way to deal with this situation is to move the demand to the periods where the demand is not so high, for example, using storage. The other way, for example, is to reduce the demand during peak times. So we are talking about demand shifting and energy efficiency, essentially, as a way to reduce the demand. And you may think that this is not so much of a problem today. You don't experience maybe this in everyday life. But if you think about electric vehicles, they are just going to make these peaks even higher, and the problem is going to be even bigger in the future. In the UK, there was a study that introduction of electric vehicles will be increasing these peaks by about 40% till the year of 2020. So really, with the demand response, we want to explore some control measures that we can use on the building, on a block of building level, to either shift or reduce these peaks. And there are two different types of demand response. So what we call implicit demand response is really to implement these measures by having sort of variable tariffs throughout the day, which will then stimulate the consumers not to use as much electricity when the prices are high and to use maybe more when the prices are low. But then there is another option, which is the explicit demand response, which are direct payments from the market for the ability to provide this flexibility in the energy demand or in the supply to the grid. In the EPBD proposal for the update of EPBD, I was very happy to see that actually demand response is one of the key elements. And this is why we are actually here today, and it's my pleasure to say that we are already working to implement some of the outcomes of the hopefully successful new recast of EPBD. So the previous speakers have talked about the smartness indicator, which talks about the possibility to assess the technology readiness level of the building to interact with their occupants, the grid, and to manage themselves efficiently. So these are the exact statements from the proposal of the new EPBD. And I would invite everybody, if you are not familiar, to have a read what is it that the Commission proposes. The second part really explicitly mentions that the way to achieve this is through the demand response technologies. So what is it that we are doing that is going to help in this direction? Well, one of the objectives of our project is to provide and validate a method of assessing at least 3 levels of technology readiness to implement the demand response measures in blocks of buildings. And we propose that first is obviously no capability at all, second will be some capability, and third is the full readiness to implement these measures. Now, how will this actually look like? I will let you know in 2 years' time while the project ends. So for the time being, this is something that we have planned, and this is something that is a very important element which will then feed into the directive. Where we are at the moment, so we are about 1 year into the project. The project includes bringing together a lot of different technologies, so integrating them in an interoperable way using open standards. Technologies come from different partners. I mentioned that we were working previously in some European projects, so part of these technologies come from our side, but we are working with Siemens, obviously. We're working with a number of other companies which are providing different parts of technologies. They are grouped in sort of 3 distinct layers. You have the market on the top side, then the aggregation of energy demand and providing the response, and the actual demand on the bottom layers, where you have different buildings with individual local energy managers communicating to the central demand response manager. They all have interaction with each other, and also the consumer portal, which provides information on what is actually going on. So this central layer, the aggregation layer, is envisioned as a cloud-based central management system, and it will be interoperable in a way that it will support not single technology providers, but also others who follow the same standards. We have defined demonstration scenarios and use cases for 4 demonstration sites, as I mentioned. And the last but not least, we have provided the first draft of business models. And when we talk about business models, it's really important to talk about the markets where these models work. So I will try to talk a little bit more about that now. First, you know that probably a lot of these European projects are trying to sort of go over something that is viewed as the valley of death, so somewhere in between the basic research and the actual commercialization. And the purpose of having really Horizon 2020 and other funded projects for implementation of research is to go over this valley of death, so having sort of a bridge to go from research to commercialization. Now, we are developing some innovative, I would say, smart technologies which are helping us, well, pushing us to do that. But we cannot really do it without the market push on the other side. And where we are with the demand response markets at the moment in Europe, you see here from 2015 report from the Smart Energy Demand Coalition, which has mapped Europe in terms of the readiness, in terms of the market readiness to accept demand response. Unfortunately, Malta is not there on the map. But you see the green countries are those that already have developed or are developing demand response markets. Red countries are those that are completely closed, and those in between are still thinking what really they should do. So not many of them are green. We are happy to have UK and France in our project as developed countries in terms of demand response markets, but we also have to deal with Italy and with Romania, which are not even measured on this map. But obviously, the actors, the stakeholders from those countries are very interested. So the industry is interested, academia is interested. The question is really about legislation. And I'm very much hoping, that the new EPBD update will help to form the European-wide demand response markets, that it will stimulate the countries that they have not developed the legislation to support these markets already in that direction. And it will be talking about the demand response not only on the block of building level, or even not only on the national level, but on the European level. And as an illustration, what is it that we have in the UK at the moment? This is a list of different demand response markets where we can participate. And we, as I said, we have developed a number of business models to participate in these markets. You see, there is quite a different possibilities. The possibilities are both on the demand and on the supply side. So some of the markets really enable the reduction or shifting of the demand. Some of them are there to supply payments for providing power reserve to participate in the market on the demand, on the supply side. And the difference is also in terms of the readiness to participate in these markets. In some of them, in some of the cases, you really have to act fast on a second notice, on a couple of seconds notice. In others, there is more sort of prediction, there is more time to react and to activate your resources and to get compensated for those participation. It can be on a minute level, it can be on hourly basis, or it can be on daily basis. So you can have a 24-hour prediction where there would be a signal on the market that if you participate the next day, if you reduce your demand or you try to provide additional supply, you will be compensated for that, and it's your decision whether to use that signal or not. So you see that there are various possibilities already. There are new markets possible to be developed still. So UK is not an ideal case where we have everything developed. No, there are still possibilities to do development there. But most importantly, we need to look at the possibilities elsewhere in Europe and transfer the knowledge we have. So where we are at the moment, we are about to start demonstration at our campus in Middlesbrough, which is this part here. These are the 4 demonstration sites that we have. After the successful trials, probably sometime later this year, we will be trying to go to these other sites and to use the experiences that we have hopefully from the successful trials from the UK and try to implement as much as we can at these other countries given the market limitations that we have at the moment. And that would mean that, for example, we might not be able to use the real market signals in some of the countries, but therefore we are developing the market emulator. This is done by the Nobatec in France. The central piece of technology, which is the demand response manager, is provided by Siemens. We are developing the local energy manager, which is going to integrate with individual building management systems at each of these blocks of buildings. And then there is also a consumer portal developed by Gridpocket, an SME in France, who will allow the users to visualize how this demand response works and what does it mean for them. This is the first prototype of the user interface that will be available for the users to see what is actually going on in their site. So with that, I would like to thank you very much for your attention. I would like to invite you to visit our website, and if you have any questions, I will be available later on, but also you can feel free to contact me via my email address. Thank you very much.